control flow and add a data flow task over here. And in this data flow task, if we add the derived column option over here, just click on this. Okay. Then you can see that you have the option to add a column over here. Let's say we add column 1, add a new column. Then you have an option to define an expression over here. Now to define the expression, you have got a list of functions over here on the left hand side, and also some variables and parameters, including your system variables. So all these system variables can be used as part of your expression. And you can also apply all these functions which are provided on the right hand side and perform some computations on your input columns using these functions and define your expressions accordingly. So in your derived column transformations, you can go and specify all, by the help of all these functions, you can specify different kind of expressions. So today we'll explore some of these functions and system variables and how exactly they work and how they can be used in your workflows. Now to be able to explore these, I'm going to come out of this derived column task and go back to the control flow and use a control flow task which is called the expression task, so that I'm better able to view how these functions actually work. So just double click on the expression task. Okay, and go to the variables and parameters option. Click on this. You'll have your system variables because there are no user created variables. So we have a system variables. Now there's a list of system variables. We'll look at a few of them to get an idea of basically how these work. So system variables basically mean these are variables which are provided by the system and which have some fixed value assigned to them. Fixed in terms of some meaningful value which is assigned to them, which might change from time to time depending on which variable we are using, what package we are in, what version we are doing. But that value is provided by the system itself. For example, we use the system container start time in our workflow previously. So if I want to use this, then I just drag and drop it over here to the system, to the expression toolbox, and I want to see what value does it contain. So I can just put an evaluate expression, and it gives us a value of 7:44 a.m. whenever we created this container. So this is giving that value as a container start time. So this value can be used in multiple places. As we saw, for defining the start date and end date, we use this particular system variable. So this system variable can be used. Then there's another system variable called the system creation name. So if we click on that, and the advantage of using the expression task to browse through these functions and system variables is basically that we have this evaluate expression option, and using this option, we can instantaneously see what is going to be the output value for this expression. This evaluate expression that has given some bulky string value doesn't make much sense, so we're not going to use it. Just ignore that. Move on to some other variable and see package name. Let's use this variable and see what it gives. It will just give you package because we have not define any explicit name. Evaluate expression, it's a package. Then let's check the username. So go to the system username, drag it over here, evaluate expression. So it is giving me my username. So this can be used to update. If we are updating any record and we want the username to be used, we can use the system username for that. Locale ID is basically the location where the system is located. So if you just pull it over here, evaluate expression, you'll get your locale ID. So this is an ID, so it doesn't have it's not a textual column. Then if we want to check out the product version, So this is basically just to show you that what all kind of information the system variables contain and what can we use them for. So this is your product version that you have been able to find out. Your system start time, evaluate expression. This is your system start time. Started at 6 a.m. So it is showing me 6 a.m. Your task name. This is an expression task. It has given you the task name. So what you would be able to get from this is basically that most of these variables contain information which is required for the audit columns which are included in all your ETL tables. So when you have an ETL table in a production environment or in a data warehouse project, along with the simple attributes, business related attributes and keys which are available in that table, you would be having some extra columns which are known as the audit columns. Those columns would be like last updated by. Okay, so last updated by, who updated this record, who last updated this record. So if that record has been inserted by your ETL process, they would expect a name of your ETL process. So in that case, you can use the name of either your package name, you can use your package name, and so that anybody who looks at that table and that record would be able to understand that this package on this date updated this record. Then you want to see when was the record last updated or inserted, when did your workflow last run. So you can use a system container start time, you can use a computer name, creator name. So all these system variables, the kind of values they contain are very useful for the audit columns that we generate. And since you use the system variables each time, it helps to keep the values in those columns across all the tables consistent. And when there's a need for debugging the data in this table, so there is some error with some data and we need to identify which process updated that record and when was it updated, on which date that data was loaded, then all these columns would help you with that debugging. So that is why these columns are important, and since they're system provided values, they can be easily used across your packages. They're available across all your packages, all your solutions, so they will give you a consistent flow and they can be consistently used across all the packages and solutions. So that is the advantage of having these system variables and these values. Now, apart from system variables, we have got a long list of functions on the right hand side which we can see and which can be used. Now, they have been categorized into mathematical functions, string functions, datetime functions, null functions, typecasts, and operators. Now, these functions are similar to the SQL Server functions in some way. They are also unique to SSIS in many ways. So we'll take a quick look at these functions and try to understand how they can help us with our derivations using the SSIS designer. So the first category of functions is the mathematical functions. So if you just click on them, you'll see that there's a limited number of functions. So there are not many mathematical functions. There's a limited number of functions. Now, some of the important functions here are the absolute function, absolute numeric expression. What it does, if you just click on that function, you will be able to see the description as well. So it simply says returns the absolute positive value of a numeric expression. All right. So if you just go and type, then you have to go and type. You cannot try to, or can we? Okay, so you can just drag and drop again the function. So absolute, just drag and drop it over here, and it says that input a numeric expression. So let's just input 5 and try to evaluate. So it gives you an evaluated value of 5. Let's put -5 and see what it gives. So it gives you an evaluated value of 5. So absolute, as any mathematical function, this is a common mathematical function, nothing specific SSIS. It gives you the absolute value, which is always a positive value. All right, then you have your floor function. Let's say we want to use the floor function. What it does is written over here, right here, returns the largest integer that is less than or equal to a numeric expression. So let's just drag and drop this over here. give it a numeric expression. So my numeric expression can be, let's say, 123, and since it will output a numerical value, I'm going to place some decimal digits as well. So 123.43, evaluate expression. Now what I get is an error message that the expression cannot be evaluated. And the error message that I'm getting is the expression has a result type of dt underscore numeric, which cannot be converted to a supported type. So whatever is the result type, this is giving it something called dt numeric, and it does not support that type. So what we need to do now is cast this function into a type that can be supported. Now, the type, since it is going to output an integer value, it only makes sense to cast this as an integer function. Now, this is your list of the casting functions, all right, and they have their own naming standards. As you can see, dt underscore I1, dt underscore I2. These are all. dt stands for data transformation. I is integer. This is 1 byte. So what we are going to do is I8. That is a standard size. That is what we are going to do. So just drag and drop it over here. dt underscore I8, and this is the format in which you write it. You first put your data transformation function in the exact same way as it is put over here. So within brackets, dt underscore I8, then you give a space, and then you give your value which you want to convert or cast. All right, let's try to evaluate, and then we have the value of 123. Okay. So if you're not familiar with the typecast functions, just take a moment to go through them, because they are not very user-friendly in the way they are written. So it's sometimes not easy to understand what they are converting it into. So because dt underscore I8, for example, this I stands for integer, so you need to be aware of that. But as you go along, you'll get familiar with these functions. Another thing is the syntax in which they need to be written. So same syntax for all. You need to specify your typecast function at the first position within brackets, then give a space, and then give your numeric expression or string expression, whichever you want to cast. All right. So going back to our mathematical functions, this is your floor function. Similarly, you have these other functions which you can use. The mathematical functions are self-explanatory, more or less, because by the name of them you can understand. So this is an absolute function. Ceiling is basically returns the smallest integer that is greater than or equal to a numeric expression. So it's the reverse of floor. Okay, it gives a numeric. It gives the integer that is greater than or equal to. Floor will give you an integer that is less than or equal to. So this is mathematical. These are mathematical functions, simple. And then you have this round function, which is important. Square function you can use if you want anywhere, but the important ones are basically absolute, ceiling, floor, and round. Okay. Then moving on to the string functions. Now the string functions, also there are limited functions, not too many, so not difficult to traverse through. Also, if we click on them, we would know what they do. So the most important ones are similar to SQL functions. Left, we already know how this works, right? You can just drag and drop. Left, give your character expression and the number of characters you want to extract from the left. So if your expression is, let's say, test, and I want to extract the first character of every word, so you can give a column name over here when you're designing your workflow, because we're just testing. That's why we are giving static values. So left, extract one column from test, evaluate expression, and you'll have T. So this is similar to your SQL function. Okay, so nothing difficult in that. Similar function is lower. It will convert all the characters to the lower case. If you have any confusion regarding the functions, you can also read the description over here and get an idea of what it does. So these are the most used functions. Ltrim will trim your spaces from the left of your string. Then you use the right expression to extract the right characters. Rtrim will trim from the right of your string. Trim will trim from all the occurrences. upper will convert to the uppercase. Okay. The other important functions are your substring functions. Again, they work the same way as they work in your SQL. So, but this is one of the very important functions because this you will be using at many places. So substring basically gives you an input column over here. Okay. For us, we are just putting test string. Okay. And then you give your start position from which you want to extract your characters. So I want to be extracting my characters from the 5th position. So I will give 5. And then I want to be extracting 5 characters. So 1, 2, 3, 4, 5. All right. So I'm going to give the length as 5 as well. And then evaluate the expression. So this gives you string. So what it basically does is start from the 5th position of the expression. So go to the 5th position, 1, 2, 3, 4, and 5. The 5th position, the 5th character is the S character. Start from there, and this is your length. So start counting 5 characters from your 5th character. So when you count 5 characters, you end up with string, string. Okay, so this is one of the important ones that will be used at multiple places. That's why I've shown you, but this is similar to how it works in SQL Server. So if you're aware of the database language, then it will be easier for you. Another one is replicate. So sometimes you have some columns for which you have no specific derivations, and they have been added to your database tables, your data warehouse tables, in anticipation that maybe in the future there might be values which are relevant for that column, and that's why we have just added them to the table right now, and future when the values comes, we'll be updating the values on that. So for the timing, what you will be doing is just putting empty strings into that, or putting, if it's a character column, then you need to put some spaces in that of that specific fixed width. So you can use your replicate function in that case. So let's say we have a column and the data type is character 5. So now in my ETL workflow, I need to be putting 5 spaces, because for character I cannot put an empty string. I can put a null, but I have decided to put not nulls. I have decided to put the spaces. So what I can do is use this function, which is the replicate function. Okay, and your character expression would be a space. So just quotes, space, end quotes, and because my data length is character 5, so I'm going to put the space 5 times to fill in all that position, because the character cannot have empty values. Oh, sorry. And evaluate expression. And if you click over here, you'll see that there are 5 values by the cursor point. You can see 1, 2, 3, 4, 5. All right. So that is one function that you can use. Then there's another function called the replace function. So this also you can use. Replace will basically replace your string. So an example of this would be, basically, if we go back over here and we put a command like this. This is basically replace, and the expression from which, or the string value from which you want to replace mountain bike. So what we are replacing, that string would come over here. We want to replace mountain with what expression do we want to replace? All terrain. So if you evaluate, then this mountain bike, the mountain gets replaced with all terrain. So this becomes an all terrain bike. Okay, so these are some of the important string functions that can be used as well. The next grouping is for the date time functions. Now these are some of the important functions, because many times we are dealing with dates and these are become a little tricky. So again, a limited set of functions similar to the SQL Server functions. So if you are aware of the SQL Server, then it will be easy for you. So we'll take a few examples over here. The date add function, just click on that and you'll see a whole description over here. So what it basically does is, you define a date part, which could be your year, which could be your month, which could be your days. Then you define the numbers, how many months, how many days, how many years, and then you define a date to which you want to add that date part. So for example, I have this example over here, date part, month 1, and get date. date add. So if I have this expression over here, what I'm basically doing is I'm adding the date part, which is a month. So I'm adding a month. How many months am I adding? One. I'm adding 1 month. To which date I'm adding 1 month? Get date. What is get date? Get date is basically again a function, as you can see over here. It returns the current date of the system. So I'm adding 1 month to the current date. Okay. So now just evaluate this expression and you'll get over here. This becomes 9th of July and it gives the same time. All right. Now the other function is date difference. Again, let's go back to the examples. All right. So how does this work? Just click on it. Date part, again, month, year, days, what you want. Start date and end date. So what is the difference between two dates and in what duration do I want it? Whether do I want the difference to be in years? Do I want to know the difference in months? Do I want to know the difference in days? That we can decide by specifying the date part. So here in this function, I have decided that I want to know the difference in months. So to mention that, you have to mention double M. Okay. Then I want to know the difference between today's date and how long it is for the new year to come. So today's date is going to be the get date. That would be your current date. And new year would be my 1st of January 2020. Now I need to put it in the correct data type format. So for that, I have used a typecast function, which is my dt_db timestamp function. All right. So I've typecasted it into the db timestamp because that is what I'll be getting my get date into. And then I have decided to find out differences in months. So how many months are there from today till the new year? So if you just evaluate this expression, it would give you 7. So there are 7 months still to go for the new year to come. All right. This is how you can use this function. Then the next function is your date part. So date part, how this works is basically whether you want to know your years. So this is basically returns an integer representing a date part of a date. Date part is nothing but a month, a year, day, all that. So if you want to know the year of the current date, you can use the date part function and you'll get 2019. Also, you can use the year function, similar function, which is a year function to get the year of your current date or the month. So this is a similar function which you can use over here. For month, if you want, I want to know what is the month, current month, then I can use this function of month of get date. I can also use year of get date to get the year of the current date and so on. So these are some important date time functions which we can use. All right. Now after that, we have something called the typecast, as we have already seen. Okay. These are different functions which are used for casting your information. So sometimes you read the information that's an AND varchar. If it's an AND varchar, that means it's a Unicode, but you are trying to write it to a varchar column, then SSIS would not allow it and you need to convert it into the proper format. So if you want to convert it to a string, then this is your function dt_string. You have to define your length and your code page. All right. Your code page is basically defines the locale. All right. So if it is English, if you're using the language English in UK, that would be your code page. Most of the times your code page is defined by a number which you need to be aware of. So 1252 is the most commonly used one for the English language. If, for example, you have to convert it to the French characters, you need to account for the French characters as well, then you have to use a different locale on code page and so on. Now, if you're writing from a varchar column to an varchar column, so you need to convert it into Unicode, then you have to use this function, which is the dt_wstr function. Similarly, you want to convert a string into a date column, a date data type, then you have to use this function dt_date. All right, so these are different functions. The DB timestamp, as we saw, we just used. So this is your DB timestamp function and so on. All right. Then you have a list of operators over here, simple operators to write your commands. All right, this was a concatenate operator, as we have seen earlier. This helps us to concatenate two string values together. Okay. And then the other one that we have not seen is the null function to check for the null values. Is null, replace null, and so on. Okay, these are your null expressions. So we'll see a few expressions now, which are made by combining all these operators and all these functions. So we'll see a few combination expressions. Okay. So let me find out a few for you. Okay, give me a moment. Okay, so now I am on this link. Let me share this link, and it gives you a good list of SSIS expressions cheat sheet. And I'm going to paste this link in the chat window. So it gives you a quick list of what are the common combinations of these expressions that can be used for computing different values. So we are going to take a look at a few of them. So let's say there is a requirement to derive the month number. Now the month number, as we know, can go on from 0 to 12. Now we cannot define a data type in our or when we are performing some computation. We need to know the exact number of digits that we'll be getting to make our checks. We do not want to be checking on just 3, which is a single digit number, or 12 at the same time. If it is going to be 3 or the third month, we want it to be 03, so that it's in a fixed format. So to do that, now this is a common requirement at many places when you're making your checks, because you cannot be making your checks you cannot have a dynamic kind of data type wherein it can store 1 integer or 2 integer. We always want it to have 2 characters in it. Then we need to add a 0 to a single digit month numbers, so that we are consistent and we always have a 2-digit month number. All right. Now they have used this expression over here, so I'll just copy it to our expressions window and see how it works. Okay. So first let's see the output. So we are using the month get date. So the get date is the current date. Current date is in June. So the month that comes out should be the 6th. And what we should be expecting in the output is not 6, but 06. And that is what we have got, because we want it to be consistent. We want it always to be having 2 digits in it. So what is basically happening over here, we can see, first of all, we are getting the month of get date, which is the 6th month. Then we are converting it into Unicode. Okay. Then we are converting it into Unicode. That is the typecast function, dt_wstr. Then we are adding a 0 to it. All right. We are adding a 0 to it. And then we are taking 2 characters from the right. Okay. So for example, if it is going to be the 6th month, then what is happening is 6 is coming over here in the month of get date. Then we are adding a 0 to it, and then we are taking 2 characters, 2 rightmost characters. So when we are taking 2 rightmost characters, it is going to be 06. So we are fine with it. But what happens if the month is, let's say, 12? So it is your December month. So the month is 12. Then we are adding 0 to it. in the beginning. Now I have actually got three characters. I do not want it to be 0, 1, 2. I want it to be only 1, 2. And that is achieved by this function write two characters. So now I'm taking only the rightmost two characters, which is 2 and 1 over here, which is becomes only 12. Okay, so this will result in always a 2-digit month number for me. Now another expression which we can see, okay, substring we have seen, replace we have seen, if is null column name. So here they have used some operators. Let me see. Okay, so this is one. Okay. Okay, okay. So I'm going to give you another link first. Now this also has some advanced expressions which you can refer to. And this is a Microsoft document. And this link itself, docs.microsoft.com. If you search for SSIS information on this, you'll find a lot of information. So this is a very good link to read about anything related to SSIS or SQL Server, and it will describe in complete details. And they also have tutorials which will help you to learn SSIS. So this is a very good place to go to. Now what we are doing over here is we are basically using this expression, and the thing that we're going to achieve over here is we are trying to see that for a column, if the first character is the first character is A, then the expression will return false. If the first character is not A, then the expression will result into true. Okay, so let's use this expression and see how it works. Okay, now this is expression. What we are going to do over here, this is a column name that they have taken. Since we do not have a column name, we are going to hard code it with a string. Now let's use something with A. So let's use A, B, C, D. Okay, that's a string. Okay. Now what we are doing over here, we are doing a substring of A, B, C, D, 1, 1. So basically you are fetching the first character from the substring, which is going to be A. Then we are going to convert it into the upper. So whether it's a small case A or an upper A, we are going to ignore the case. That's why we are converting it to upper. And if it is not equal to A, we are checking if this is not equal to A. In this case, this is equal to A. So this should evaluate to false. So this is false. Okay, so this exclamation equal to sign is basically not equal to. Okay, now if I change this A to, let's say, B, now my first character in the string is not an A, so now this expression should evaluate to true. True. All right, so here we have used these operators. Okay, this, as you can see here, is unequal. Performs a comparison to determine if the two expressions are not equal. Okay, and the output that you get is Boolean. So this is in terms of true or false. Okay. Now another thing I want to show you is basically something like if then else. Okay, so let's take a simple example of if then else. So this part, let's just take this part. and see how it works. Okay, go back over here, copy this. So what this is doing, if null middle name, all right. So we are going to change the middle name to a hard-coded thing. So let the middle name be again be Adams. Okay. Then there's a question mark. Then we are going to take the substring of the middle name, and the middle name we have hard-coded. So let's just put it over here as Adams. So we are going to take the first character and concatenate with a space. Otherwise, we are going to leave it as empty. Okay. First, let's evaluate this and see if this works. This is an A. All right. So what is basically happening, and what basically I'm trying to show you here is that we can write an expression similar to something like an if then else, and how it works is basically this exclamation over here is an if. This question mark over here is a then, and this colon over here is an else. So what is basically happening over here is, if is null Adams, so we are checking now, we are also using the null function. If this string over here is a null, okay, then if this condition is true, then, so this question mark is then, take the first character. So if is, okay, so this is if is not null, because this is an exclamation, so this is unequal. If is not null, if this is not null Adams, then question mark is then, take the first character. So this is substring Adams 1 1, so this is getting the first character of the string, and concatenate it plus with a space, and then colon. Colon means else, just put an empty string. Okay, so what we are doing is we have put an exclamation mark. Exclamation mark is if is not. Okay, so if is not is null Adams. So if this is not null, then you take the first character of your string, that is Adams. This will be A in that case. Otherwise, what you need to do is note it by your colon. So just put an empty string. So now in this case, this is not null. If this is not null, then take the first character. So it has taken A and it has evaluated it to A. Okay. If this would have been null, then it would not have done that. So here also it would evaluate it to empty. Or it would evaluate it to Adams, because we have this value over here. Oh, sorry. Okay, so this is going to be an empty string. If I remove this and put Adams and Adams and evaluate, then nothing. And I will put is not null. Okay, so is not null is not a function. Is not null is not a function. That's why we have to put that. Okay. Okay, now let's reformulate it. Basically, what I'm saying is, if is null, so I'm not going to put a null value over here. So this is not null. If it is null, then I just want an empty value. Else, denoted by a colon, I want this value. Okay. So this is an A. Okay. So this is an if then else. What is basically written over here is, so there's nothing over here. So if this is an if is null, this question mark is then, and this colon is else. Okay. So if is null, whatever is the value coming in here, if it is null, then just pass an empty string. If it is not null, then take the first character, extract the first character, and output it by concatenating it with a space. That is what you are doing. So instead of writing an if then else, you just leave it over here. Okay. In place of then, you put a question mark, and in place of else, you put a colon. Okay. Now, since there is no is not null function, how can we make it an is not null function? By simply prefixing it with an exclamation mark. So now this becomes is not null function. Okay. So this is an important construct in the expressions when you are creating some complex expressions, and you can use this to create your constructs. All right. Now this is another one. Now this is a simple combination of simple functions, but what they are trying to do is something that you might encounter in many places. So let's just put this into quotes to hard code this and just make it like this. Okay, and similarly over here. Okay, wait, and you get color. So what they are doing over here is that they are reading an input column, and in this case we have hard coded, and then they are putting it in the proper syntax by making only the first character of that word as in the uppercase, and all the remaining characters or alphabets in that word as in lowercase. All right, so upper, they're extracting the first substring, converting it into upper, then concatenating it with all the remaining substrings. So we know that there are 15 characters. Okay, so all the remaining of them, starting from the second position, they are making it into the lowercase. So that is what is happening. So you can have your input column name over here, and you can use your input column name. So that would be a parameterized value, because we are not having any input column sourced to our expression builder currently. That's why we have used a hard coded one. Okay, that's why we have used a hard-coded value. So this is how you can play with these functions and use them while building your expressions using different tasks. You can have your expression tasks wherein you build your expressions at the control flow level. You can have different expressions on your data flow task and different transformations like the derived column transformation and so on. So these will be used at various places. You can also use your expressions while defining your variables. So you can, when you define your variables, you have an option to define their values in terms of expressions. So if you click over here, again, you'll get a similar window wherein you can use your variables and parameters. You can also use your functions and use them on your input columns and define your expressions. So these are all these functions which are available, and we have seen various uses, various ways in which we can use them. For more, as I have shared these links, you can go to these links, go through them, and you'll see various uses of how these various functions can be used in combination with each other. Okay, so this is about these tasks and these functions. These are known as SSIS functions and the system variable. So they can be used at multiple places, very powerful to make your whole thing dynamic, and to allow you to use these expressions and variables in multiple places in your packages and your solutions and your projects. Okay, so this is a very good way of doing things, and very powerful way to add the transformations to your source data. All right.